Yeah, am I audible now? I didn't notice this one. Yeah.
Yes, yes, you are audible, sir.
Suman, I guess I'm not able to hear you. Okay. I think. Yeah.
No, sir, I just
Have
said
you
that you are
guys
audible.
gone through week three? Soman, I cannot hear what you're saying.
No, I just said you are audible, sir.
Is everyone else able to hear Abhijit Soman? Okay. Okay. Let me just rejoin. Yeah. Sorry, I was mute again. Yeah, I'm not aware of a tan 2 calculation manually. You can look up a table that already has predefined calculation. Yeah, you are allowed to discuss week 4. So we can take up week 4 questions also. Yeah. Can one of you, open like switch on your mic and speak something? Am I getting your audio or not? Let me just see that. Yeah.
Yes, sir.
Yeah, the audio is faint. Okay. Nevertheless, we can use the in-call messages. So feel free to ask your doubts over there. I'm not able to hear people. I do not know why. Uh, yeah. Okay. So okay, it's almost 4:05. So we'll get started. So, do you guys have any doubt in week 3 assignment? Because this will heavily depend on what we have covered in week 3. Your week 3 is due this Sunday, right? Okay.
Week 3 was due on 17th of August, sir.
Sorry.
Week 3 was due on 17th August. The due date has already
Okay,
passed.
passed. All right, all right.
Yes.
Okay, no issues. Okay, we'll go with week 4 content. Yeah, so basically you have three types of problems. One is fairly trivial, that you have to convert a DH table into a transformation matrix. How is it different from week 3? Is that you have to go through a series of calculation to reach there, and here are the entries for the DH table, and you have to convert this into a transformation matrix.
Sir,
So, yeah,
sir, I just want to know the derivation for the transformation matrix formulas.
yeah, we have covered it last week, right? Pranav, you were there, right?
Yes, I was there, but actually it didn't work. There's a formula for it. I searched in net. I just want to know the derivation for it.
Okay, this is
What are
not
the
something like
NEPT
a
rules?
derivation. Yeah, this is just a series of calculation that you do. Okay, so nevertheless, I'll just quickly explain that. So we have followed this convention, that first we do a di translation along zi, so zi minus 1. Then we do a theta I rotation along zi minus 1. Then we do a alpha, AI translation about xi, right? And then we do a alpha I rotation about xi. Yeah, Pranav, uh, this will give you a transformation matrix, and that is for one entry of a TH table. Yeah.
Yes, sir.
This we have covered before. I'll just show you quickly.
Then we multiply everything in the reverse order.
It's not a reverse order. Please don't use such terms. It's not a reverse order. What you do is an operation followed a series of operations. First, you translate, then you rotate, then you get a new axis. You translate about the x-axis of that frame, and then you rotate about that frame, that axis. Right? It's a series of transformation or rotation or translation. Yeah. So these are not reverse order of multiplication or something like that.
Okay.
Yeah. Any doubts from week 3? Is calculator allowed in exam? I'm not aware, Pratyush. Probably uh, you'll have to ask. But as far as I remember from my days when I was giving an NPTEL exam, you have a calculator on screen. So yeah, it has basic calculation. So you can have a tan inverse calculation. Yeah. For trivial things, probably you don't require, right? Only when your tan inverse is like 0.3214, something like this, you'll have to use a calculator, right? But then for tan inverse 1, 1 by, what can we take? 1 by root 3. Yeah. So those kind of things, you don't require a calculator. And mostly they'll ask you such kind of things. Yeah. Okay. Let's get started. I think this week is uh, really easy um, in terms of concepts and amount of things that you need to work out. So first question is that you need to find Jacobian of a scalar manipulator. Does anyone know what a scara is? like the full form of SCARA.
Selective Compliance Assembly Robotic Arm.
Articulated robot arm. Yeah.
Yeah.
Uh, but what do you mean by compliance?
Yeah, it has compliance in one plane. I mean, for pick and place operation, this kind of robot can be used. So it gives you compliance in same plane.
Um, what do you mean by compliance?
Maybe the motion is in that particular plane. I'm not sure, but I have seen the robot in videos and during the lecture as well. So it has motion in that particular plane.
Yeah, it has motion like in every other plane, like only in one plane, but then you can have different planes where the motion is going on. What they mean by compliance is that in the axis where it is a pick and place,
Yeah,
let's take if you
Z
have
axis.
yeah, it can be in different axes also.
Yeah, yeah,
Don't worry about it. Yeah, in that axis, let's take I'm picking something, but then I travel more than what I should. It is not going to affect my robot or the platform. So it is compliant in that direction. What it means by compliant is accommodating errors or human um, errors or even elasticity. Right?
yeah.
Although this is not a real compliant robot, uh, so anyway, they have named it this way. We can't help it. Right?
All right, sir. Got it.
Yeah. So let's work with this problem. So here they have asked us to find the Jacobian matrix using the end effector position. So we know. Okay. Give me a second. Yeah. We know that our Jacobian is equal to dou f1 by that variable, one of the variables, dou f1 by dou y, dou f1 by dou z. Given that my x, y, and z are my variables, and f is the function whose Jacobian I'm interested in finding, right? So like this, I'll have n entries till dou fn, dou x, dou f fn. So this is nothing but a gradient of a gradient. If you take your f1 as a gradient, so this takes the gradient of it. So that way you can realize this, right? So here our variables are theta 1, theta 2, and d3, right? So our px, py, pz will depend on the entries of these values. That is what actuating parameters mean. And d1 and d4, they are just constants. So in your partial differentiation, they will go away. So that is what we need to remember. Yeah. So since we have three actuating parameters, our Jacobian matrix will be, we have three functions, that is px, py, and pz. So it will be a 3 cross 3 matrix, right? So Jacobian, using this formula, we can calculate. At first one, we partial differentiate with respect to theta 1. So you would get minus k1 c1, sorry s1, minus k S1 minus 2, right? And then we take with respect to theta 2 next. So you would get this one would be 0, and then minus, there is another minus sign, so becomes plus k2 s1 minus 2, right? And then with respect to d3, it's going to be 0. Then we come to py. There again we'll get k1 c1 plus k2 c1 minus 2, and then with respect to theta 2, 0, minus k2 c1 minus 2, and then again in d3 it will be 0. Yeah. Then the last pz is going to be 0 in every other entry, minus 1. This is going to be your Jacobian for this case. So this is how you can solve this problem. Yeah. So the second one, I'll go to do you have doubts in what I have explained? Please discuss week 3, 10th question. Pratyush, I don't remember what is the 10th question. Can you just help me? Just to tell you people that I'm not making the assignments. But okay, let me just check once. What do you mean by it? 10th question. Okay. Okay, what do you want me to discuss in this? It's an objective type, right?
Yes, yes.
Yeah, please go ahead. You can elaborate.
Okay,
Uh,
okay. Just there is three answers are there.
yeah,
Okay, just explain this one. What you call the locus? It means first and second answer. First one, the locus of the tip. Then the
they are
value
not
of
the answer, right? They are false.
false. Yeah, it is. Explain that.
Okay, okay. The option, you want me to
Yeah, yeah,
option
yeah, yeah,
explain the option. The
yeah, yeah.
locus of tooltip when value of theta 2 is held constant, and we vary the other two joint variable in spherical shape. Okay, what it means is that see, there is no speaking in terms of grammar. This is not a statement, right? But nevertheless, what it means is that you're trying to find a locus of the tooltip. Locus meaning that the trajectory or the uh, instantaneous location of tooltip
Correct.
traversed when theta 2 value is held constant at 0, and you are varying theta 1 and d3. Because of what you are varying and what you have kept constant, you'll get a locus of whatever you are interested in, right? So that is
Mm.
what they have asked. This is not a statement. So uh, poor marks for grammar to them. So yeah. So actually, uh, most of the NPTEL questions, if you follow the grammar, you'll you'll get the answer. So here the right one is holonomic because you know you
Yes, yes.
you are
That is correct.
controlling every.
Remaining are false.
Many of them are false. Okay, we'll move to the second question.
Correct.
Okay. Oops. Yeah. So here, like I had explained to Pranav, what you do here is you get to a transformation matrix that is from I minus 1th frame to ith frame, that we do by a series of transformation, that is di about x zi minus 1, theta I about zi minus 1, ai about xi, because you have transformed about your z axis. Because of that, you would get a new frame. In that frame, you traverse by ai about x axis, and then you have alpha I about xi, right? So you would come to an expression that will look something like this. Okay, let me just do it. Even I don't remember the expression. Yeah. So um okay. So this will be your uh, okay. Let me not introduce dummy frame. Okay. So this one will be 1 0 0 0 C alpha minus S alpha 0 S alpha C alpha A I 0 0 1 0 0 0, and this one would be cos theta minus sin theta 0 sin theta cos theta 0 0 0 1 0 0 d I 0 0 1, right? By multiplying these two matrices, you would get a transformation matrix, right? Let's just do it. C theta, C theta
Sir,
plus, yeah,
sir. So for each transformation, we multiply the x component matrix and z component matrix.
yeah, because we work with two frames, right? Two axes only, not the y axis.
Yes, sir.
That is the basics of your DH parameter, right?
Yes, sir. So this is how we formulate the formula.
Yeah, this is your by your definition derivation, right?
Yes, sir.
Yeah, okay. Yeah, this is your matrix. Now, what you need to do is substitute these values in this equation. Like, okay, let's try it. Right? The first one will be from t0 to 1. That what kind of entries do we have? Cos theta 1, c theta 1 minus s theta 1, 0. What is a 0? What is alpha pi? Cos pi is again 0. Cos pi is 0, right? No, 1 minus 1. Yeah, theta. Cos alpha, right? So this is your first transformation matrix that will take you from this frame to this frame, right? And then you need to you'll get another transformation matrix that will be T1 to 2, right? And from there you would get T2 to 3. So to get T03, you will go in the order T01 transformed to T12, then T23, right? So by just doing this, you'll get your answer for this such kind of problems. From this, they can ask you what is the end of arm location. That is nothing but this particular column, excluding the one normalizing factor. Yeah. So this is how you solve problem 2. Okay. Yeah.
Yes,
Any
sir.
doubts?
Understood, sir.
Yeah. Okay. Now here we have a problem where,
Sir,
yeah.
sir, as I mentioned, I just went in the internet and saw a formula.
Mhm.
I just want to know both are same or not.
What is the formula?
Can you read it out, sir?
Yeah. Yeah. Good.
Yes, sir. It's cos theta I
Okay. Hmm. Good.
minus sin theta I cos alpha I
Okay.
sin theta I sin alpha I and ai cos theta I, sir. That's the first line.
No, it is not right. Also.
So it's wrong, sir.
Yeah.
Okay, sir.
So just remember this transformation, right?
Yes, sir.
So, yeah. Over here, right? Here, what was the formula given in lecture? Prana?
Sir?
What was the formula given in lecture?
Sir, I don't quite remember it, but um, yes, sir, I think I don't remember it, sir.
In
1 second,
first
sir.
row, in first
Uh,
row, it is c theta cos theta minus cos alpha sin theta. Yes, it is first row c theta cos theta. Second column minus cos alpha sin theta. Third column sin alpha sin theta, and fourth column a cos theta. That is AK. It means first 0 to 1. So
Yeah. Okay. Let me just review it once. Okay.
in second column C alpha will be there.
Second column.
Yeah. Second column, first row.
Okay.
minus C
cos
alpha S theta 1.
S theta. You correct.
Minus C alpha S theta.
Here.
No. Just before that.
Sir, shall we tell you row wise? Will it be
Yeah.
okay for you if we go
Yeah.
row wise?
Good. Good.
Okay. So, sir, I'm telling the elements for of the first row, all four elements of the first row.
Okay.
It is C theta 1. First element is C theta 1.
Mm-hmm.
First row, second element would be minus C alpha 1 S theta 1. Others can cross verify.
Mm-hmm.
Minus C alpha 1 S theta 1. Third element is sin alpha 1 sin theta 1. S
Correct.
alpha 1 S theta 1. And last element of the first row is A1 C theta 1.
Correct.
Yes, sir. This was the formula I saw in
Pratyush,
the net,
you
sir.
may please cross check
Yeah,
this.
yeah. No, there. I think this one needs some more correction because you will not get
Yeah,
AI coming as such.
right.
Yes, sir. Also, this was the formula I saw in the net, sir.
Yeah, yeah, I get that.
Yes, sir.
Okay. I'd suggest you to um, follow that formula for now for this thing.
Sir, the one you just derived, sir.
No, no, no. The one you guys just done on the internet.
Yes, sir.
Give me a second. Okay. Let me review this and get back to you next class. Um, because we wouldn't get this answer. Right? Let's try this. 1, 0, 0, 0, C alpha minus S alpha 0, S alpha C alpha times A 1, 0, 0, 1. Right? About x axis, you will not have any rotation. Yeah.
Sir, can I read out the full formula, sir?
No, no, no. I get your query, so don't
Yes,
worry.
sir.
So A1 C alpha is there, right? C theta, C alpha.
Yeah. At the
Yes,
last.
sir.
Yeah.
First row,
Okay.
fourth.
Let me get back to you with that. So you can you follow that problem. Sorry, follow that formula. I think that is right. I'll get back. Okay. So
Anyway, px is a c theta, right, sir? A into cos theta. It is
yeah, yeah.
quite clear. And
It
then
is obvious
py
that
would
that
be,
one is right.
yeah, py would be sine theta into a, and
Yes,
then along z it would be d, whatever is given.
that's correct.
Okay, no,
But
no
we
problem,
should
sir. No problem.
get in this manner also.
Yeah, yeah,
That
that's
is
right.
where
No,
I
no
was
problem, sir.
looking into.
Yeah,
Right.
yeah.
Okay. Okay. We'll just move ahead. Um, follow that formula. That would be correct. I'll rectify that and just it. Yeah. So again, here
Okay, show me, sir, once that what you got, sir.
from
Okay, okay, stop, sir. Okay, basically this formula you got, it is from tk minus 1 to k. It means ti minus 1 to 1.
hmm.
Okay, whatever we are saying, it is tk to tk minus 1. It means just reverse.
Yeah, yeah, that is what I was looking because this is the way you would get to your transformation matrix. But what you are referring to is a multiplication from RZ and then
No, no,
RX.
no, no. I mean to say that it is base to tool. Okay, you got from tool to base. It's somewhat like that. Here,
No, what I am doing is a base to tool.
but the it is matching with that. So.
Hmm. Okay, wait, let me try. One. Hmm. Okay, I'm not able to figure it out now. Let me just get back to you later. Okay,
Yeah,
so
sir. We can move forward at this point of time, and then we can discuss it later
yeah,
on if others are okay with it.
Correct, correct.
yeah.
No
Yeah.
worries.
Yes, yes.
Okay, so here again we get to the transformation matrix from 0 to 4. From that we take the translational vector, that will be your px, py, pz, right? So once we take this, um, derivative of that will give us our Jacobian matrix, right? So that is the first part where you have AQ, right? So your Jacobian matrix will look uh, AQ, which is a partial derivative of the end effector location, and then BQ, which is the orientation of it. So how we define BQ is that you have a eta parameter that only contributes when you have a rotational joint. So you can see what BQ does is it deals with, right, the moment at the end effector, the moment that you exert at the end effector. So hence you can think that the rotational elements will only contribute, and the formula for BQ goes that EK Z K minus 1. Why are we taking Z K minus 1? Because it is our joint axis. Yeah. Yeah. So in this problem, i- it is trivial to find AQ. That, I guess, how we have done for problem 1. We can do it similarly, right? And then, yeah, for BQ, here you can see that uh, all only my fourth axis is rotational, and other all axes are prismatic, right? So because of that, my BQ will come out to be yeah, 1 times Z3, because this is the fourth axis. Now my Z3, what is my Z3 is rotational matrix from 0 to 3, and then that is multiplied with uh, a vector that represents Z axis, that is 0, 0, 1. Right? With this, we'll get our Z3. Right? Yeah. I think I'm getting the issue that we had in transformation matrix. Right? Because our first entry, the AK, this would come something like this. And from that, we'll get our variables. But then, anyway, I'll get back to you next class, because that way also we should be getting. But unfortunately, there is some issue that I have done. I'll rectify that and get back to you. Okay. So this is how you would get your BQ, and this will um, be like a vector, not like a vector, like a matrix, something like 0, 0, 1, 0, 1, 0, or something like this, right? So based on that, you can use this both and calculate anything that is given in tool space to joint space. Okay. Now, times this one will be Jacobian times x, which is equal to q, right? So your Cartesian space to joint space, it converts this way. So the inverse of it will be, right? Yeah. So the inverse of it will be your Cartesian space with respect, yeah, your Cartesian space multiplied, sorry, your Jacobian multiplied with q, right? You can always not have inverse, so you work with pseudo inverse. Here, um, your values will come out to be like 1, 0, 0, or something like that. It will be a index kind of a matrix. So, so you can also use J transpose times F. Right? So actually, this is the formula, right? J transpose times the F in Cartesian space will give you your joint torques. Yeah, follow this. So these are the three problems that you'd find challenging in this week, and rest all their theoretical course. theoretical questions. Yeah. Any doubts?
Okay, how to do 8 and 2 calculation from calculator?
You would have tan inverse, right? That is 8
Yes,
and 2.
that is arc 10. 8 and 2 is another one.
Yeah, 8 and 2.
Arc 10 will be, it means it will cover the range of the theta 1, theta
Yeah,
2. Arc 8 and 2 will be
you can
cover all.
convert it by adding, like, by converting the range of it, right? That way you can get 8 and 2, right? So your arc tan inverse has a range from say A to B, then your uh, arctan 2 has another range. You all have to do is scale that range. You have to convert it to that range. So it's the same thing. And if it goes beyond the range, you convert it back to that range. So you can find A tan 2 in the book they have given as a reference material, John Craig. So you'd find arctan 2 calculation from that. So we have the book here. Wait, give me a second. You can refer from that. I do not have the book in my lab. I'll get back to you on that also. So let me just put a reminder. Okay. Yeah. Yeah. Okay. I'll get back to you regarding these both. Okay. Or maybe I'll post it, updated it in my notes. You can refer from that. I'll be posting this rectified transformation matrix today, so you can see through it. Okay. Okay. So, do we have any doubts? Any further doubt? All right. I guess there is no further doubt. Right. We'll close this session.
Okay, practice assignments shall we do?
Yeah. Yeah. We can. Go ahead.
Okay, question number 14. Question number 14 and 12.
I do not have access to your current assignment, but okay. Let me
Practice
just.
assignment. Practice
Yeah. I
assignment.
don't have access to that. I have access to previous year questions. Okay, which week were you referring to? Fourth week.
Yeah, yeah. Fourth week.
Fourth week. No, previous year there was no non-graded assignment. Yeah, Prathamesh, go ahead.
Sir, do we also have to join at 5 to 6 session?
No, no, no. It is either or it's up to you. You can attend both. You can attend only one or neither. Yeah.
Yes, sir.
It's just to help you solve assignment. Nothing.
Actually, this was my first day.
Okay, no issues. Okay. I Pratyush, can you post the questions on messages, or is it? It will be too tedious, right?
because it contains graph,
Images.
images and graphs.
Okay, let me try. I'll give me a second.
Please provide the email ID. I'll just post it.
No, no, I am able to access
Okay.
from my account.
Okay.
So, nevertheless, week 4 practice. Yeah. Which question in this?
12, 14.
12 and 14. Okay. Consider a roll pitch, roll twist. Okay. Which of the following statements are true?
The degree of freedom has to be considered
Degree of freedom need not be considered. No, they have given
because
you.
because singularity, it means that rank will be reduced when the degree of freedom is obstructed. It means limited.
Uh, no, there are two types of singularities. One is when your axis will have too much of a torque to get out from a configuration. The other one is a restriction on theta, right? A robot cannot make a 360 rotation because there will be wires, there will be bulky components, right?
Okay, it doesn't have to do with degree of freedom.
Degree of freedom. No.
Okay, so they have provided theta 2 is equal to 0.
Yeah,
The rest has a similarity when theta 2 is equal to
theta
0.
2 is 0. Yeah. When theta 2 is 0, uh, look at end effector and
Yeah,
arm end.
its
They align.
motion its motion will be obstructed when theta 2.
See, one thing, they have not given the reference from where it is 0 or things like that. So I'll take the present configuration as 0,
Okay.
right? So when arm end is aligned with end effector, this one would become a singularity, right?
Okay.
So a singularity is when a degree of freedom is lost,
Correct. Correct.
right?
That's what.
So that you can think of. If I turn my axis too much, it is going to hit something, and 1 degree of freedom will be lost.
What I understood that if theta 1 is it means it's kept stationary,
Hmm.
it's it is somewhat, it doesn't affect the what you call yaw motion.
Yeah.
But when theta 2 is kept as what is static, at that time we can't able to move that what you call yaw motion.
Yeah, motion. Exactly.
So in theta third one, it means theta 3.
Yeah.
It means
Theta 3 0 and theta 1 0. Both of them are same, right?
okay, okay,
They
yeah,
both are
yeah,
not similar.
theta 1, 3, 3, correct, correct.
Yeah.
The last one, the reach doesn't possess any similarities.
No, it does,
Oh,
right?
yeah, you're wrong.
Theta 2 is 0.
Yeah, correct. Good.
Yeah. Then 14th.
Yeah.
Consider the forward kinematics of 2 degree of freedom 2 link planar arm given in week 3. Okay, lecture 4. Okay.
After
Possible joint velocity
yeah,
depict.
after getting the Jacobians, how to
Yeah.
process I didn't understand. We can find the
Maximum
Jacobian.
velocity links on the circle. Even I'm not clear what they are asking. And
Okay.
the arm is in the configuration theta 1, theta 2, 0 and 30. The unit circle in the joint space gets mapped as an ellipse. Okay. Which of these do you think the unit circle would get mapped if theta 1, theta 2 is 30 and 0? Okay. Px 1, 2. This is a planar 2-link manipulator. You'll have to work it out. One thing is that your Jacobian will change. Your Jacobian matrix will change because
Yep.
your entry of
After,
theta 1 and theta 2 has changed.
yeah, after finding the Jacobian, we can put the theta 1 and theta 2 values.
Okay.
Up to that, it's okay, but how to map? Is not clear.
Okay. You take it this way. You take this circle as a unit circle. Okay, they have given unit circle, right?
Yeah,
So at theta 1 dash, wait. Okay, 1 second. Give me a second. Yeah. Now everyone will be able to see that. Okay. Now you take this entry, which is 1 comma 0, this
mm,
entry which is 0 comma 1, and this entry which is minus 1 comma 0. Take any three entries and see where it maps in this ellipse.
mm, one thing is theta is there. It means 0, 90. We have to consider that. No? 0, 0,
Uh-huh.
theta to
Sorry.
this. No, no, there is not numbers. No, angle will
Which
be
one?
there. Theta to that circle is provided over there.
No, no, this is theta 1 dash.
Yeah, yeah, theta 1 dash at the what do you call it? At the circumference.
Mhm.
We have to consider angle. No,
No, no. 1 radian per second. You can
or
take it that
radian.
way. No?
Radian means
1 radian per second or something 1 degree per second also you can take. A unit circle will not matter, no?
oh,
Yeah. Look at where these points would map on this ellipse, right? So based on that,
they have provided this theta 2 dash and theta 1 dash. Okay,
yeah,
after that they have using the Jacobian, they have
mm,
got the p dash y and p dash x.
yeah,
After that, what they did, they have just flipped that. It means theta 1 became 30
yeah,
degree and theta 2 become 0 degree.
yes,
After that, we have to find that what's the mapping will be done for the py and px dash.
yeah. So that is what I am telling you. take any 3 points. So, technically speaking, if you have to do such a problem comprehensively, you would require some programming skills so that you take every point of this boundary and map it with that yeah, I think I lost my voice. My voice was
Yeah.
lost. Yeah. So you take these points, right? All of these points actually. But then now you for manually you can select few points and then use this Jacobian that you are getting from flipping these angles theta one and theta two,
Mm.
and based on that see where these point map in Cartesian rates, right? So that way you would get. But I think it will
Provided
resemble
answer.
like
Yeah.
the ellipse it already had,
Provided answer is in a linear fashion. This
linear
one.
fashion.
Yeah.
Yeah,
Yeah. This one
yeah.
is.
It will be like this or this way,
Yeah. Yeah. Correct.
right? So this is nothing but shrinking.
Singing correct. Correct.
Yeah. So this continuously shrink and becomes a straight line, or it will thicken, become something like this. So the form will remain the same.
Correct. One last question. Eighth number. How to find the Jacobian eighth number?
Yeah, this one we just did right
Mhm.
here. The okay
Yeah. Yeah. But how to find Jacobian in this? I didn't understand.
Jacobian. Okay, wait one second. They have not given you manipulator configuration, right?
PX, PY, PZ.
Where is it?
Those eighth number questions.
Yeah, 8 number, right? This
Yeah.
one.
Yeah. Correct.
But they have not given you the configuration that you are using. Okay. Uh, I think you have to use the SCARA manipulator. Right?
Because in classwork also they have provided one question in that just angle were provided and we have to find the Jacobian something.
I'm not aware what you mean. So, this type of question that we have discussed now, they give you the Jacobian matrix. Sorry, they give you the configuration DH table, and from there you get to Jacobian. I guess in this problem they missed out on the figure. Maybe I'm not so sure. So that could be a possibility, but you can use no the kinematics of SCARA for a practice. But then here you
We
see
have to
F1, F2, F3, and torque 4. This is for a spherical arm like what we dealt before, just in problem 3. The type of problem 3 I was referring to. Yeah. So that will have this kind of configuration F1, F2, F3, and then uh, torque 4, tau 4. Because tau is the end rotation, right? So D1, D2, D3 are the translate prismatic axes. So you will have F1, F2, F3. Yeah.
correct.
Use that configuration to find this.
Okay, I'll do.
Yeah, Pratish. Guess that is all right. You have any further questions?
Thank you.
Okay. Thank you, guys.